So let's do the induction. OneWayAirlines has maps. To make it simpler, let's call these OWA maps. This will be an OWA map on in cities. It will be a map so that any different cities has a route between them. Because then we can state the problem as, given any OWA map on in cities, there is a sequence that visits all of the cities. We can do this by induction on n. In the base case, we look at OWA maps with n equals 0 cities or n equals 1. Where 0 city is the empty sequence works, and for 1 city we just list that 1 city. In the inductive step, we consider OWA maps with more than 1 city, and we get to assume the induction hypothesis that for any k between 0 and up to n, OWA maps with k cities will have a sequence that visits all of the cities. We now want to show this for our given OWA map, which we'll call M, that has n cities. Here we'll slow down because now we have to think. How do we break this apart? Well, we can do it by picking any city B from the map, and that B will split the set of cities into all of the cities that you can fly from and reach B. And we can write that as a set of all cities A so that AB is a flight on the map. We can also then have all the cities that we can get to from B. The way I'm going to say that is by taking all of the cities, subtract out B, and subtract out F. And that will make sure we don't repeat any cities. Because if I actually said the ones I can reach to, well, some I can come from and to, and I don't want to duplicate cities. Now, F and T are both going to be sets of cities that are smaller than n because we've removed B. And if we look at the map on F and T, each one is an OWA map because we're just throwing away cities to get the map on F and to get the map on T. So both of them are OWA maps. Smaller, the induction hypothesis applies. We use the induction hypothesis to get a sequence of all of the cities in F that we can visit. And we use it again to get a sequence of all the cities in T that we can visit. And then we just need to join these cities by B, because from any city in F we can fly to B, and from any city in B we can fly to T. This visits all of the cities in M. And therefore, QED